Algebra 2, Section 5.1. Chapter 5 is all about quadratics, quadratics that yield the graph that's called a parabola. The name of the section is Modeling Data with Quadratic Functions. To start, we'll talk about what a standard form of a quadratic is. You might think, hey, we already have a standard form. That was ax plus by equals c. Well, that's standard form for a line. There's a lot of standard forms in math, and this is standard form for a quadratic. F of x equals ax squared plus bx plus c. What you should know about this is that the ax squared term, so this term right here, that's ax squared, that's the a, b, and c are numbers. So, if this is 3x squared, that term, 3x squared, would be the quadratic term. What causes it to be quadratic is the fact that it has x squared, and that term would be called the quadratic term. This term would be called the linear term. Linear because you think about, slope-intercept form, the fact that there's a slope and a y-intercept, that there's a slope and the independent variable in that position of y equals mx plus b. Well, that would be, the mx would be the linear part of that line. And then the c is the constant. Now, what we're not saying is that this is linear. No, this is not. This is something that produces what's known as a parabola, okay? So the whole thing is quadratic. This is the quadratic term. This is the linear term. This is what's known as the constant. And their graphs will produce a parabola, always like this U-shaped parabola. Put arrows on the end of it when you graph them. And every parabola is symmetrical about a vertical line, okay? Every parabola that we'll deal with in Chapter 5 is symmetric about a vertical line. That line that I have dashed in blue here is called the axis of symmetry. And then the point that is the low point for parabolas that open up and the high point for parabolas that open down is known as the vertex, okay? So with that, we'll do some examples. Oh, one quick thing. What if a were 0? What if a were 0? If a were 0, wouldn't that make the quadratic term non-existent? And then you'd have a line, right? So if a is 0, you don't have a parabola, you don't have a quadratic, you have a line. All right, so again, looking at some examples. It says determine whether each function is linear or quadratic. Identify the quadratic, linear, and constant terms like we just talked about. You should be familiar with FOIL, so I'm just going to roll through the first couple here. Be able to FOIL 2x minus 1 times itself. This is not a distribute the squared in situation. Please don't do that. FOIL here, 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 and here, and then simplify, and you'll get 4x squared minus 4x plus 1. That is quadratic. You could identify 4x squared as the quadratic term, negative 4x as the linear term, positive 1 as the constant. And that's what they're going to say right there. Okay. Same directions. X squared, and then again, you could FOIL this, and they'll do that for you. In this step here, after you've FOILed this, it's still in parentheses because you're subtracting the entire product here, and that product meaning, multiplication. That's what that is, multiplication. You're subtracting the entire thing, and then if you distribute the negative and simplify, you will get 1. Okay, so this is not quadratic. This would be actually a horizontal line. Y equals 1. Remember, f of x is the dependent variable, so this is the line y equals 1. It's linear. And you can still identify the terms. I'm not exactly in agreement with that. If there's no quadratic term, then there's no linear term either. So not exactly in agreement with that, what they say there. All right, below is the graph of y equals x squared minus 6x plus 11. Identify the vertex and axis of symmetry. Identify points corresponding to P and Q. There's the graph. The axis of symmetry is actually missing, or is actually going to go right here where there's the grid line is missing, okay? So do you identify that the vertex, they even said it here, the vertex is this point, which is trying to be 3, 2, and it'll be clear once the line is in place. There it is, okay? So that is the line x equals 3. When we ask for the axis of symmetry, this is key, this is so important. Please give us an equation. Do not just say 3. That's going to be at least a minus a half every time. It is, the line is x equals 3 to distinguish it from, what horizontal lines are. All of the axes of symmetry that you will identify in Chapter 5 will be vertical lines. You should identify them by their equation, x equals 3. Just the same, make sure you identify the vertex by its ordered pair as they have done. Okay. Now maybe you remember the notation in geometry of prime, right? So this point right here would be P prime. This point right here would be what we call Q prime, and you can identify them by their ordered pair, this would be at 2, 3. Q prime is at 2, 3. P prime looks like it's at 5, 6. And they do correspond because they're symmetrical about the axis of symmetry. Okay, moving on, I've got this one over on the starboard. Basically, what you have is, well, let me get over to there. So basically what you have is an input and an output 3 times that we're being told is on the quadratic function. So what you're going to do is take f of x, or I'm just going to use y, equals ax squared plus bx plus c, standard form, and plug in -2 for x, -17 for y. -17 equals a, -2 for x, like this, plus b times -2 plus c. If everything that we did so far is a little bit easy, buckle up, because this one's a little bit harder. This is kind of the key point to the lesson, so make sure you can do this. I'm plugging in 1 for x, so 1 squared plus b times 1 plus c, and then -10 is equal to a times 5 squared plus b times 5 plus c. All right, now let me just fix that up a little bit and see if you recognize what this is going to be. First of all, I'm going to flip things around the equal sign. You'll see why I'm going to do that in just a minute. I'm also going to simplify what I can with the squareds and the negatives, all right? So this would be -2 squared is 4, so 4a minus 2b plus c equals -17. And then we're going to have 1 squared is 1, so a plus b plus c equals 10, and then we're going to have 25a, because 5 squared is 25, plus 5b plus c equals -10. Now what does this remind you of? Should remind you of the matrix problem from chapter 3. We're going to solve a system here, okay? Now just to save time, I have already typed these into my handheld calculator, and just to remind you of the keystrokes, I'm now going, because I've put 4, -2, 1, 1, 1, 1, 25, 5, 1 into my 3 by 3 matrix, and then the other 3 into my 3 by 1 matrix, and I'm going to go A inverse B in my home screen, and I get, see, the variables are, well, you know what, I'm sorry, I jumped ahead of myself just a little bit. You would want to show the matrix setup. 4, -2, 1, 1, 1, 1, 25, 5, 1. The variables here are not x, y, and z. They are a, b, and c. Okay. Now, I call them variables with a little bit of caution because they're not really variables. We're going to figure out what they are and then use them as coefficients in the quadratic that we're trying to find. It's going to be the a here and the b here and the c here. But in this system problem, they're unknown, so we can call them variables. -17, 10, -10. Now, as I was saying, I did this in my calculator already. I did this work right here. I did A inverse B, and it turns out that A is -2, B is 7, and C is 5. All right, now you got to know what to do with that. What are we trying to find? We're trying to find the quadratic in this form, whereas these 3 points are actually lie on that parabola, are actually solutions to this equation. And I just found out that A is -2, that B is 7, that C is 5. What you're going to write then is y equals -2x squared plus 7x plus 5. This is that equation. As you do the homework, make sure you practice this with diligence and that you understand what you're doing and that you practice accuracy. This is likely to be on the quiz and the test by hand. We will require it to be by hand. And now, saying by hand, I don't mean that you have to solve the system like like plugging things in and using elimination, that kind of thing. No, you can use matrices, and you should, but by hand meaning that you cannot use the last thing that I'm about to show you on the last example here, which is called quad reg. You cannot use quad reg. You have to show this amount of work here. I should see the matrix setup. I should see this for sure. Really, I should see all 3 things. You probably could get by with this and this, although there'd be a high probability of error if you didn't do the kind of intermediate step here. Okay, now with that being said, you could get this another way. And that would be using this function on our calculator called quadreg, which I'm about to show you. And what turns out to be the case is that it takes 2 points to make a line. I'm sure you know that. It takes 3 points to make a parabola. 3 points, that is, that pass the vertical line test. 3 unique points that would actually fit on a parabola. It only takes 3 and you can get a perfect parabola. More than 3 and you probably don't have a perfect parabola, although our calculator still has a function that will model a parabola, and that's the key word, model. We talked about it when we did linreg, that you are going to find a model by using linreg when there seemed to be a positive or a negative linear correlation. Now we're going to do that with a quadratic. So going to the last problem here, notice that there are 4 ordered pairs, not 3 but 4. And who really cares? I'm going to try to keep this video short, but who really cares what this information is? We want to find a quadratic model. Use the model then, where are we going? To model the data. That's the key word. And then we're going to use the model to estimate the wave speed of a deep water wave that has a wavelength of 6. Okay? So really, again, this is X and this is Y. For the purposes of our calculator, this is L1 and this is L2. Now again, for brevity, I have already entered those into my calculator. Let me show you. Not second, sorry. Those are those 4 ordered pairs. Now you want to push stat, right arrow over to calc, and remember linreg was 4. Now we're going to use quadreg, which is 5. We're trying to find a quadratic that will model this. So that's quadratic regression. You see the ones below, we'll use these in chapter 6, cubic regression and quartic regression. There's down here is 0 is exponential regression. We'll do that in chapter 8. Okay, but I'm going to use 5, quadreg, and then it looks just like it did when you did linreg. And here's your answer, okay? 0.5, if they told us to round to the nearest hundredth, I'd say y equals 0.59 x squared plus 0.34 x minus 0.33. Make sure you're rounding correctly too, whatever we tell you to round those values to, okay? And I think the software does use that. So, yeah, they rounded to the nearest hundredth. So this right here is what we just said. That's using quadreg, okay? And then finally it says to an approximate model, at a wavelength of 6, we could plug in 6 into x. Now, last thing I need to say is, yes, you're going to plug 6 in for x, but you'd probably get a -0.5 on us on the quiz or the test if you did it with this model. Going forward, what we want you to do is to remember this here, graph it in your calculator, and then find it for 6. Okay. So again, remember that it's y equals bars. 5 is statistics. Right arrow, enter. On this problem, sorry, I want to go to my calculator, not that. After I've run quadreg, I can go y equals. Make sure nothing's in here. You got anything in here, clear it out. Vars, statistics, which is the 5 button, right arrow over to equation, and it's going to reference the regression equation. Okay, it's going to put it all in there. Okay, and then zoom 6. I don't know what it's going to look like. We'll just see. Okay, maybe you want to zoom out just to see. And they wanted it for 6, so now I can just go trace 6, enter. 22.89. And again, I'm not sure, I didn't check. But if they wanted that to the nearest hundredth, 22.89 is accurate to the nearest hundredth. I don't know what you'd get if you plug 6 in here into these rounded values. Don't use the rounded one. Use the exact value one by using y equals bars 5, right arrow, enter, and then use the trace function to trace right to the point that you want to get to. Hope that made sense. Good luck on your homework. Thanks for watching.